Imagine sitting down to a fresh salad where the lettuce was grown on the moon and tomatoes ripened under the Martian sun. It sounds like something out of a sci-fi novel, but it's closer to reality than you might think. Space farming isn't just a dreamy concept for foodies and astronauts, it's an essential step in humanity's quest to colonize new worlds. With NASA's Artemis missions already paving the way for lunar agriculture, it's time to talk about what it will really take to grow dinner in the most inhospitable places imaginable. Forget your backyard garden. This is farming reimagined for the final frontier. Why farm on the moon or Mars? Space travel isn't just about putting boots on alien soil. It's about thriving there. The ultimate goal is to make extended stays possible and eventually permanent habitation. NASA's Artemis program aims to use the moon as a testing ground for technologies and practices that could one day support human life on Mars. And what's at the center of all long-term survival plans? Food, of course. There's nothing like biting into a crisp piece of fresh produce, except that food production in space is no simple feat. Without local farming, astronauts are stuck with the logistical nightmare of resupply missions from Earth, which is neither cheap nor feasible for longer missions to Mars. The moon's proximity allows for agricultural trials under extraterrestrial conditions, and it may even serve as the site for humanity's first true interplanetary garden. After all, growing food right where you need it is not just a matter of convenience, it's about survival. Plus, let's not forget, a garden with a view of Earthrise would make gardening worth the extra effort. The Artemis missions, setting the foundation for lunar agriculture. NASA's Artemis missions are well on their way to making the moon habitable, at least partially. Artemis 1, launched in late 2022, was an uncrewed mission to test NASA's mega rocket, the Space Launch System, and the Orion spacecraft. This mission's success laid the groundwork for future crewed missions, like Artemis 2, scheduled for 2024, which will take astronauts on a flyby around the moon. The real groundbreaking moment will come with Artemis 3 in 2025, when astronauts will land near the moon's south pole, an area with resources crucial for agriculture, namely water ice. This mission will not only see the first woman and first person of color on the lunar surface, but will also be the starting point for longer lunar stays. Establishing a base here with local resources for farming is key to Artemis' long-term goals. The astronauts will set up systems and experiments that are designed to sustain human presence and prove that lunar agriculture is possible, despite the many challenges of low gravity, extreme temperatures, and radiation. Where water and plants meet. Why target the south pole of the moon for human exploration? Because that's where the water is, and water is the elixir of life for farming. The South Pole is rich with water ice, locked away in craters that have never seen the light of day. These dark craters, forever hidden from the sun's heat, contain water ice deposits that are essential for drinking, turning into breathable oxygen, and critically for agriculture. Imagine harvesting water directly from lunar soil to feed hydroponic systems that nurture vegetables and fruits. That's the vision, and it's a big part of why Artemis is so focused on this region. The water is also useful for machinery, making it a multi-purpose resource for sustaining a long-term base. By planting crops and utilizing local water, astronauts won't have to rely solely on supplies brought from Earth, thereby slashing mission costs and logistical hurdles. Experiments on lunar plant growth. The Lunar Environmental and Agricultural Facility Experiment. Growing food on the moon isn't just about dropping a seed into some dust and hoping for the best. It requires carefully designed experiments, such as NASA's Lunar Environmental and Agricultural Facility Experiment, set for 2026. Lunar Environmental and Agricultural Facility will focus on plant photosynthesis, systemic stress, and growth responses in the moon's unique environment, complete with low gravity and high radiation. This isn't the first time plants have been introduced into space, but it will be the most sophisticated attempt yet to understand how to cultivate life on another celestial body. Back in 2019, China's Chang'e 4 mission managed to grow cotton sprouts on the lunar far side. However, those plants perished in the intense cold of the lunar night. Lunar Environmental and Agricultural Facility aims to overcome such challenges by leveraging advanced controlled environment systems, which will not only help grow plants but also ensure they're nutritious enough to sustain astronauts. Not just for show. The practicality of space farming. Water on the moon isn't just for sipping tea while admiring Earth's glow. It's about turning H2O into rocket fuel. Through a process called electrolysis, lunar water can be split into hydrogen and oxygen, potentially becoming a vital resource for future rockets leaving the lunar surface. This would make missions from the moon significantly more sustainable, as spacecraft could refuel in orbit rather than hauling all of their propellant from Earth. Farming on the moon isn't just about feeding people, it's about supporting machines too. In this vision of lunar agriculture, plants would help to recycle waste and purify air, while harvested water would double as fuel for propulsion. It's a circle of life, space-style, where every resource plays a critical role. If successful, these methods will be crucial for reducing mission costs and making interplanetary travel a feasible endeavor. The moon is the gateway to Mars. NASA considers the moon as a critical proving ground for future Mars missions. Why? Because the moon is just 3 days away, while Mars takes at least 7 months to reach. This makes the moon an ideal place to experiment with new technologies and techniques, like farming. Any issues that arise can be addressed relatively quickly compared to being stranded millions of miles away on Mars. Artemis will study how limited gravity, about 1/6 that of Earth's, affects both human health and plant growth. If we can make it work on the moon, the knowledge and techniques we gain will be directly applicable to Mars. With plans to set up a habitable mobility platform, NASA envisions astronauts staying on the lunar surface for up to 45 days, learning everything they can about how to live sustainably off Earth. These lessons are pivotal, as any successful agricultural strategy developed on the moon will be adapted for Martian conditions, which, although different, pose similar challenges regarding radiation and gravity. Martian farming challenges, not your grandma's backyard. Mars presents unique challenges when it comes to agriculture. Unlike the moon, Mars has a thin atmosphere composed mostly of carbon dioxide, which could theoretically be used by plants. However, Martian soil, called regolith, contains perchlorates, a type of salt that is toxic to plants and people. This means extensive soil treatment will be necessary before it's even usable for agriculture. Then there are the Martian dust storms, which can envelop the entire planet and last for weeks, complicating any attempt to grow food outdoors. Yet Mars also offers advantages. With some atmosphere present, albeit thin, it's possible to provide some radiation shielding for crops, and the lower gravity, about 1/3 of Earth's, might even make certain agricultural tasks easier. NASA is hoping to overcome these challenges by first trying out all proposed techniques on the moon under controlled environments. Once successful, astronauts will know exactly what works and what doesn't, giving humanity a fighting chance to grow food on the red planet. Blue Origin's Blue Moon. Lunar greenhouse on the horizon. NASA isn't alone in the effort to make lunar agriculture a reality. Blue Origin, in partnership with other aerospace companies like Lockheed Martin and Boeing, is building Blue Moon, a lunar lander that will be crucial in supporting scientific and agricultural experiments on the moon's surface. The Blue Moon lander is being designed not just for landing humans, but also for delivering payloads necessary for establishing a sustainable base. This means infrastructure for agriculture, including greenhouses and other farming equipment, could soon be delivered to the moon by Blue Origin. These collaborative efforts indicate that lunar farming is not some distant dream, but a planned, funded part of the mission. With industry giants like SpaceX and Blue Origin working alongside NASA, the future of lunar agriculture looks promising. Imagine a base where fresh produce can be grown, harvested, and eaten by astronauts, reducing their dependency on supplies from Earth and allowing them to focus more on the mission at hand. Gateway Station, Moon's food pantry? The Gateway Station, set to launch in lunar orbit by 2025, will serve as a mini space lab. With docking stations for crew and cargo, it will play a crucial role in ongoing agricultural research and resupply missions. Gateway could potentially act as a food storage and processing unit, taking some burden off the lunar greenhouses and ensuring astronauts always have fresh produce within reach. Gateway will also help assess the long-term impact of deep space on the human body, a sort of cosmic farmer's almanac, but much more advanced. Thanks for joining me on this journey into the fascinating world of space farming. If you found this video as exciting as I did, imagining fresh veggies growing on the Moon and Mars, make sure to hit that like button and don't forget to subscribe to stay updated on more out-of-this-world content. Together, we'll explore the future of space, technology, and beyond. See you in the next video.